Hi. So today we're going to talk about how to visit and how to modify the network parameters using the PyTorch. And so those parameters are including the weights and biases, right? So those are two different kinds of parameters that we have in the neural networks. Okay. So and then we're going to also talk about this a mechanism of the parameter sharing. Okay, good. So let's begin. So let's have this x. Okay, so that would be a tensor with dimension 2 and 3. So let's have this network as a linear with 2 and 1. Okay, so let's have a look on this x and net first. Okay, so that's going to be those two, right? Okay, so after that we want to so here we put this transpose. Okay, so we simply print x and the transpose of the weight. So this would be, so here we are visiting this the parameters, right? So this would be the weight of this linear and this would be the bias of this linear. Okay, so this layer, right? So essentially we have this matrix, or this is a tensor, or this is a two-dimensional matrix in 3×1, and after we transpose, this becomes a 1×3, right? So you can see that this would be the after the transpose, right? And this is the bias. Okay, and although we have this bias in only one dimension, okay, so here it simply has one number, but later we don't have to worry about the dimension of the biases, okay, because PyTorch, it has another mechanism called broadcasting. Okay, so we don't need to care about to align the dimensions for the biases. Okay, so that's something else we're gonna talk about later. So let's simply focus on the weight first. So we know that we use so everything here that is about this matrix multiplication, right? So that's something using the linear algebra. So okay, so next we're gonna show some equivalent ways of doing this kind of operation. Okay, so this kind of matrix multiplication. Okay, so the very natural way of doing this, or the implicit approach of having this this net x. Okay, so that's gonna be this. Okay, so let's have a look on this. So this is simply saying that we're gonna do this matrix multiplication with this x, and then with this transpose of the weight. Okay, and then we plus then this bias. Okay, and we're gonna argue that this is also equivalent to this something as follows. Okay, so because we have another dimension here for so this can be called batch, right? If we have more dimensions before the last dimension, we can give some names for those dimensions. But here, if we have only 2 dimensions, we can call the first one here as the batch. Okay, the batch size. So this would be an efficient way to do all those operations at the same time for all those batches together. Okay, you can see we have all those batches in this x, right? But you can even separately compute those batches. Okay, and later you can put them again together after computing this matrix multiplication. Okay, so you can simply do that, do those 2 different multiplications. Okay, in the first, we're gonna have, so here, okay, so because we're gonna have this, we're gonna to pull this the first dimension in x, so the first element in x, right? So that would be the first batch. Okay, and then we're gonna squeeze this. So this is simply to make sure that this is still in a matrix in a tensor in a format of tensor, right? So that we can use this MM as a matrix, right? So then this has a so here we will have this. This is not 4 and 3, right? So it's gonna be let's see. So if this net is 3 and 1, so this has to be 1 and 3, right? Okay, because we simply know that this weight has the shape of the transpose of this this linear. Okay, so this would be having the same dimension of this linear. Okay. All right. So here, okay. So what's the dimension of this x? So this x is 2 and 3, right? And this will be 3 and 1. So together this will be 2 and 1. Okay. Although we have this as only one dimension, okay, but we don't have to worry about that because, as we said, there is some broadcasting mechanism, and that will automatically broadcast to other dimensions to match this dimension. Okay, so we don't have to worry about this. So, and then this is one way, right? So the other way that we just talked about is that we can separate those two, split those the dimension of the batch, and we do this for the first batch. Okay, and then we need to adjust the order. We need to change the order of those things, right? Because here we're gonna have this. So this is gonna be the dimension of 1 and 3, right? Okay, and this has to be 3 and 1. Okay, so this is gonna be simply 1 and 1, 1 by 1, right? And this is also a 1 by 1 tensor. Okay, so let's print this and have a look. Okay, so those two are the last two that we just mentioned, right? This is for the first batch, this is for the second batch, and you can simply use some other operator to simply concat those two together, right? In a correct dimension, in a correct way. Okay. All right. So, and you can see this. If you put those two together, that will be exactly the same as the previous approach that this PyTorch, the linear operator that uses implicitly, right? Okay. All right. So as a little note here, we can notice that. So here I put all of those notes. So let's have a quick look at this. So when we're doing the matrix multiplication, so the weights they're just automatically transposed. Okay, so we don't. So we simply need to write this 3 and 1. Okay, and we don't have to care about the to make some transpose. So this is done implicitly, right? So when we call this function, call the net of x, then that will do this automatically, right? So we don't have to worry about this. And then this will be able to do this matrix multiplication in the correct way of those dimensions, right? So namely, what we have is that, so here we have the dimension of this x to be batch size by the input features, and this transpose of weight, that's going to be the input feature by the output feature, right? And then plus the bias. So bias, that will be just having some output feature in one dimension, and that will automatically broadcast to the other dimension with batch. Okay. And finally, this y, this output, that's going to be the batch size by the output feature. Okay, good. So, and so here I put a little note for this broadcasting mechanism for this bias. So in the linear, so the bias is simply a 1D tensor, okay, with the size of this output features. So, and that can be added to the result of the mm, okay. So where we have mm of x and weight, the transpose weight. So so this is essentially what we were talking about, right? So this X has this size and a weight has this, and then the broadcasting is that. So now we have the result of this, right? So this result, as we mentioned, is going to be the dimension of batch multiplied batch by the output, right? So, and the bias simply has one dimension of those. So then the PyTorch also implicitly it helps us to broadcast all those, right, to the other dimension of batch size, and it simply replicates, okay, across the dimension of batch, okay. So for example, this is another example, right? So we just this is essentially the same as we just talked about before, right? So we have input x 3/2, and the weight is 4/2, and then we're gonna have this transpose, right? So the output is gonna be 3/4, and you have 4 biases. Then after the broadcasting, then this becomes 3 and 4 to match this, right? So use those 4 numbers and to replicate in those dimension of 3, okay? And where each row is this bias. Good. And or we can separate compute for each batch, as we just mentioned here, right? So this would be an alternative approach, but normally we don't need this, right? So but in some extreme case, you might. This is just helpful for us to know, right? We can do this batch by batch, but we don't really need to bother to do this. So the implicit way would be this, right? And we don't need to even write this, right? So we can simply write this, net x. So PyTorch will automatically do this for ourselves, right? Good. So, and the dimension for the last approach, for this alternative approach, that's going to be the weight, that'll be the out by in, and then matrix multiplication with each dimension, right? And that's going to be in feature by 1, and plus the bias, and that's going to be out feature by 1, right? And combine those together, right? Okay, good. So that's a very important part of this parameters, right? So now we know how to do the matrix multiplications for the input and those parameters, right? So this is a very necessary and important part to understand. Okay, now we're good to move on. So the next, so next we're gonna have this have a look on this. Okay, so we're gonna have this net. Okay, there's a linear value and linear, and I'm gonna have this x to be some 2×3 matrix. Okay, so normally the way of read or visit the weights and the biases are using this state dict, right? So and you can also simply use this bias or weight. Okay, so let's have a look on this. Okay, so let's print. Okay, so we're gonna have this state dict. Okay, so that's going to be your order dict, as we mentioned previously, right? So that includes this weight and bias. Okay, and this is for the first, right? So for the 0 element, that's going to be this, right? 3×4. Okay, so or we can also call this and this is a class of n dot parameter, and we can even use this, right? So we can even just call this net 0 bias or the net 0 weight, right? In the way of visiting this data, we can just use this data, right? So the shape is just the same. Okay. All right. So good. So that's going to be so you can see from this, right? So this would be essentially exactly the same as this. Okay, so those are exactly the same way, essentially the equivalent ways of visiting those parameters. Okay, if you want to visit this, you can simply change this to 1, and to visit this, to change this to 2, right? Okay, good. So as grad, that simply means that we can visit the status of the grad for those parameters, weight or biases, right? So, and here this is still noun because we haven't done this backward function yet. Okay, we're gonna introduce that later. So now we don't have any grad yet. Okay, good. So next we're gonna introduce this named parameters function. Okay, so we have this net the same as before. So we can print this. Okay, so what we're gonna print is that, so we have those two. Okay, and in the net 0, so remember net 0, that's gonna be this, right? And named parameters. Okay, so let's have a look on this output here. Okay, so for those named parameters, so we simply print all those names, right? So now we're gonna know what is the name for all those parameters. So this is going to be the second element, and then this is going to be the weight, and so on and so forth. Okay, if you print net 0, and that's going to be this. If you print for all, and that will include all of those two, right? So this and this, right? And ReLU doesn't have any parameters. Okay, that's just some activation function. Good. And we can even collect the parameters from some nested blocks. Okay, so let's define our block 1 to be some sequential with those things. Okay, and some block 2, and we're gonna say that we're gonna put so here we use some add module. Okay, so we're gonna iterate. Okay, so from this block 1, we're gonna put all of those iteratively, okay, inside of this, right? So here we simply so let's say that we have this net, right? And then we simply insert or nest all of those block inside here, right? So that's gonna be our block 2. And then we even add another linear after this block 2 to make this sequential. And let's have a look on this nested net. Okay. Okay, so then we can print this. Okay, so this nested net that looks like this. Okay, so let's verify if we are correct on all of those, right? So the first, that should be some sequential, right? And okay, so let's see. And then we're gonna have this linear. Okay, so this has to be sequential first, right? Then we put all of those inside of the sequential, right? So that's what we are doing here. So the first, that would be this linear, then ReLU, linear, then ReLU, right? And then we do this 3 times, okay? And then we put another linear. So that's exactly what we did. Okay. Good. So next, so it'll be important to know how to initialize the parameters, right? So this is also a very important part of deep learning. So we can use the normal distribution, or we can use the uniform distribution, or we can even use some Xavier initializing. Okay, so there are a lot of methods. So for example, there's X, and we have the same net. So we define this init normal. Okay, so that takes some module. So if there's a linear, then we init this. Okay, so we're gonna call this module underscore. So then we put this weight here. We can initialize weight or bias. Okay, that's up to view, and we're gonna call so this would be the parameters for this normal underscore, right? So underscore simply means that directly change those numbers, right? Those values. Okay, so then we have the mean 0 and standard deviation of 0.05, and we're gonna put all of those zeros for the biases. Okay, so, and then we apply this function to this net, and then we're gonna call those and have a look. Okay. All right. So this will be drawn randomly from a normal distribution, and we have a 0 for the bias. Okay. Good. And we can also even use some constant. We just already had some constant, right? But we're gonna so 0 is also constant, right? So but here we're gonna introduce another constant function here. So this would be just constant underscore, okay? And this would be the constant that you wanna define. Okay, so this simply gives us this constant, and this is what we have here. Okay, and you can even use this so-called Xavier uniform. That's just another method of initializing. Okay, you can have a look by yourself later if you're interested in this. So that's just some other function, right? You can just call this and to initialize. Okay, good. So, and then we can even sort of define this constant. Let's say we put 100, okay, for those weights, right? So you can do whatever you want, right? Good. So, and you can even customize our initialization. Okay? Let's say we can define some new init function, okay, and now here we print this. Again, we print those architecture, right? And then we simply init uniform for the weight, and so here we can do those for those different layers, right? So this is gonna be our first layer, this is gonna be the second layer, and remember the first one should be this linear, right? And then that's gonna be this, right? Okay, good. So then we can initialize our weights and biases, right? Good. So let's have a look on this. So we have let this so we let this 0, okay, and so right, so here we simply, right, for this net 0, okay, we applied two different initializing functions, right? So here we applied this constant 100 version, this function, to the layer 0, okay, and then we apply this new init, this one, to the layer 2, okay. And then let's have a look on those two layers. Right, so after the initializing, right, and then this becomes like this, right? So this is the 100 version for the net 0, and the new init version for this for the net 2, okay. So that means we can even assign those different functions for different layers, right, for the initializing. So this is also very important to know. Good. So, and even we can do this by brute force, right? So we can even just change those numbers, like we can just write those numbers, right, for those places. We can just add 1 to those, and we can just let this all the other after 1 to be 10,000. Okay, so something like that. Okay, and this, for example, this gives us this, right? So that means we can even just write some numbers inside of those parameters. Okay, Good. So the last thing for today, we're going to talk about this shared or sharing parameters. Okay. So this is also very important, right? Sometimes we need to share some important, such as in transformers and something else, right? So we need to share some same parameters across the network. Okay. So let's define this shared as a linear. We're gonna put this shared twice. Okay, so let's have a look on this, and we're gonna print the net2 and net4. So simply that'll be this and this, right? So, and then later, so let's have a look on this first, and that's true, right? So those two, they're essentially the same. Even if we change some number, let's say to some -5, some number in layer 2, okay, and this, although we have changed this, and this should still be true, okay, although we change this to -5, and those two, because they are sharing the same parameter that we defined here, this has to be true again, okay, although we have changed some number. Good. So that'll be everything for this episode. So we discussed the parameter sharing, and we introduced how to visit and modify those parameters, right, in neural networks, okay, which are important for us to continue on the further discussions in the neural networks. Okay, good.